Hi there, folks. In this lesson, we're looking at modeling quadratic functions, and really this comes down to interpreting word problems that end up giving us quadratic functions, and then finding a piece of the quadratic depending on what it asks for. All right, and so really it comes down to the same thing that we typically do when we're solving word problems, and that's coming up with the equation that we need. Okay, we're just expecting them to be quadratics this time. So, for example, if I look at something like this guy. There's 40 feet of fencing available to fence in a rectangular area. Find the length and width that will yield the largest area. And so we want the biggest area possible using this 40 feet of fencing. All right, so the first thing I would probably do on this one is draw a quick sketch of the situation. So let's say we want to create it in a rectangle that looks like this. Keep in mind the idea that we have 40 feet of this thing. And so as we start to label this, maybe I'll call the width X. So each of those would be X. And then those other sides would also be the same. However, I don't want to use a different variable. I want to use the same variable. The thing that I have to consider here is the fact that, if we're talking about 40 feet, that means that this guy and this guy, just these two sides together would have to be 20 feet. Okay, and then likewise, just these two sides together would also have to be 20 feet. And so if I kind of cut this apart and just look at half of this thing, all right, it means that if I just look at those two pieces where one of them's X and the whole thing is 20, well, that would mean that if this piece is X and the whole thing is 20, then this guy must be 20 minus X. Okay, and so when you think about it, like if one piece is 10, the other piece would also be 10. All right, if one piece is 15, the other piece would be 5. Okay, it's 20 minus that. And the reason, again, that I use 20 is because the whole thing would be 40. And so as I kind of look at it this way, that means this side would also be 20 minus X. All right. The other way you can look at this now is as you add up all the sides, does it add up to 40? Do I have 40 feet of fencing? And the answer is yes. So the X's end up canceling out and I'm left with just 40. Okay. But now it wanted me to find the area and talk about the area. It wants me to maximize the area. All right. And so if I'm talking about the area of the rectangle area would equal length times width. So it's just X times 20 minus X. Okay, and so now if I wanted to simplify this a little bit, I would distribute the X. So that would be a 20X minus X squared. And then I might even rewrite it this way. I might say, hey, a negative X squared plus 20X. All right. But now from here, the idea is that I want to maximize this area. And so as I think about the equation for the area here is a quadratic, which means if I were to graph this thing, it would be a parabolic curve. And so if I just think about the graph for a moment, this would be a parabola that opens down because the a value is negative. So if that parabola shows me the different areas that I could have, maximizing the area is just a matter of finding the value that's at the very top. Okay? And so as I start to think about this, maximizing the area, I want that point right there. That's the point at which the area is at its largest. Okay? And so again, if the function that we get is a parabola, well, that parabola is describing the areas we could have. And if I want to maximize the area, well, I'm looking for the highest point on that parabola. Okay? And so when I think about what that means, the idea here is that it's asking me to find the vertex. All right, it goes back to that lesson where we were looking at the different parts of a quadratic and the different parts of a parabola, and determining based on the context and based on what it was asking, which thing do I want to find? Did I want to find the y-intercept or the x-intercepts or the vertex? And if so, which piece of the vertex? Okay, and so in this one, I want to find the vertex. All right, so to find the vertex of this one, I do opposite of b over 2a. So the opposite of b is a negative 20 over 2 times a, which is a negative 1. And so I simplify. That gives me a negative 20 over a negative 2. So that gives me a 10. All right, and so that's the x value. And so if I come back over here, that's the x value. Well, that's this guy right here. So it's saying, hey, this side right here should be 10 units, which means this side should also be 10 units. So the thing that's going to maximize the area is doing something that looks like a square, okay? And so when it said find the length and width, well, we've found both of them at this point. The length of this thing should be 10 feet. And the width of this thing should also be 10 feet. Okay? And when you think about it, let's talk about the area just a little bit. If I think about the area of this thing, it didn't ask me for this, but the area that I would get would be 100 square feet, length times width. So think about any other combination that we could have here, all right? If I were to think about any other combination, let me draw one off to the side. Let's change that from a 10 to a 9. Watch what happens. If I change this to a 9, then this has to be an 11, okay? And now the area, even though it's still 40 feet total, if I work my way around, that's still 40 feet of fencing. I only get an area of 99 square feet. Whereas in the example we just did, by doing 10 and 10, I got 100 square feet for the same amount of fencing, okay? Let's change it maybe a little bit more drastically. Go a little bit skinnier. Maybe I'll go 5 on this one, and then this would be 15, okay? And so again, as I work my way around, this is still 40 feet, okay, as I work my way around that thing. But if I find the area, 15 times 5, that's 75 square feet. Here, let me write it inside here. And so what I'm finding is that the measurements that I found give me the biggest area. If I compare different ways that I could do this, I continue to have 40 feet around the thing, but I can continue to get areas that are not quite as large, okay? And so as I look at this parabolic curve, if it's describing the area, here's where that point of 99 was. Here's where that using a 5 was, okay? And so we find that I get areas that are not quite as large, okay? So there it is. Length is 10 feet, width is 10 feet, okay? If we look at this next one, last year, Mr. Jansen's Clown Emporium sold 500 rubber chickens at $10 each. It's estimated that for every $2 increase in price, 20 fewer chickens will be sold. So as I raise the prices, less people are going to buy. That makes sense. What should the price of the rubber chickens be in order to maximize the income? All right. So first of all, let's talk about that idea of income. All right. If I think about what happened last year in this example, it says that 500 rubber chickens were sold, and they were $10 each. So let's figure out the income there. It was basically the number sold was 500. So we sold 500 of them. The price of these things were $10 each. And so hopefully you go, okay, if you sell 500 at $10 a piece, well, 500 times 10 is 5,000. So the income off of the rubber chickens was $5,000. Okay? And so that's the basis we want to start with. How do we find income? Well, it's the number sold times the price. But now I'm changing the number sold and I'm changing the price. So let's talk about the new number sold and let's talk about the new price. Okay? And so this is from a perspective of changing the price. So let's talk about the price first. It says that it's estimated for every $2 increase in price. So the price was $10. Let's start with that. It was $10, but I want to increase the price. I'm going to add to this price. And let's think about what I'm adding to the price. Well, I'm adding $2 increments. All right. And so be careful here. It's not just plus $2. I'm not just going to go $12. I might go $14. I might go $16. I might go $18. It says I'm working my way up in $2 chunks. Okay. So I'm going to call it 2x. All right, because I don't know how many increments I'm going to move, okay? I want to go in $2 increments, but I don't know how many of those. Am I going to increase it by $2 once? Am I going to increase it by $2 twice, so $4? Am I going to increase it by $2 three times, so $6? All right, so it's 10 plus 2x. And now we want to approach the number sold the same way. I started with 20 people, right? Oh, sorry, 20 fewer people. So I started with 500 people last year, and now I'm going to decrease the number sold. I'm going to subtract increments of 20 for that. And once again, I don't know how many increments of 20 because it's the same number of increments as I'm increasing the price. So I'm going to subtract 20. Well, it's x again, all right? If x is the number of increases, well, that's how many decreases of 20 customers I'm going to have. All right. And so that idea of I don't know how much I'm going to change this. I'm going to go in, I'm going to start at $10 and add chunks of 2. That's the 2x, is chunks of 2. All right. I'm going to start with 500 is what I sold last year, but now I'm going to lose customers, so I'm going to subtract chunks of 20, so 20x, okay? And so now if I think about how I calculate income, looking back up here to calculate income, I did the 500 times the 10. I did the number sold times the price I was selling them for. And I do the same thing here. I do the number of sold times the price. So if I want to find the income on this one, I'll call it capital I just multiply the number sold times the price. I multiply these two things together. This is where the quadratic comes from. This is going to give me a quadratic as I multiply this out as I distribute. And so I distribute the 500. That's going to give me a 5,000 plus 1,000x. And now I distribute the negative 20x. That gives me a negative 200x and a minus 40x squared. And so now I'm going to combine like terms. I'm also going to rewrite this because I want to have the x squared first. So it's a negative 40x squared. See, I'm putting it in the right format. Plus 800x when I combine like terms. And then plus 5,000. Okay? So now I have this quadratic that's in standard form. This quadratic represents the income. And once again, if I think about this in terms of a graph, I know that this is a parabola that's going to open down. I've got a negative a value. But that parabola, that curve describes my income, all right? And so if that curve represents my income, I want to maximize my income. I want the highest point on this curve. I want the point that's at the very top. It's asking me to find the vertex, okay? And so to find the vertex of this one, I do opposite of b over 2a. That's a negative 800 over 2 times a negative 40. So let's see, that's negative 800 over a negative 80. And so it looks like when I kind of reduce this thing, it looks like I get a 10. So it's saying x should be a 10. And here's the thing, that worked out to a nice, neat number. It could be a decimal too. If I get a decimal, it means instead of doing a $2 increase, I might do a $3. So it's somewhere in between those $2 increments, okay? So this one's going to be a nice, neat increase. But now it asks me, that's the x value. That's how many times I should increase the price. If I want to find the price, well, I've got a nice little equation right here. There's the price. It's 10 plus 2x. So if maximizing the price is an x value of 10, well, I just have to plug a 10 in here. And if I plug a 10 in here for x, I get 10 plus 20, which is 30. Whew, that is quite the increase. So it's saying that I should sell these for $30. Which means I'm going to lose a lot of customers, okay? But if we kind of follow the math here, again, it doesn't matter that I'm going to lose those customers because I'm going to make so much more on each rubber chicken, okay? So the price I should sell them for looks like $30. That answers the question, okay? The follow-up question here, however, says how much more will be made this year, all right? So compared to last year. So last year we said it's 5,000. This year, well, let's find the price. And there are two ways to do this. The first way is I can look at this and say, well, I found one of the pieces of the ordered pair for the vertex. I found that x is supposed to be a 10. But right here, this is an equation for income. So if I want to know the income when I use an x value of 10, I just have to plug a 10 in here. I have to find the rest of the vertex. And so if I do this, again, use parentheses when you plug this in. That's a 10. Here in parentheses. And when you punch this into the calculator, if you used parentheses like I just did here, if you punch this in exactly the way it's written with those parentheses, your calculator will spit this out correctly. All right. Students tend to get things wrong when they plug things into a calculator because they don't use parentheses as much as they should. Okay. And so if I plug that 10 in, it looks like the I value, I get the income, gives me a 9,000. Okay, so that's one way to find the income for this year is to plug it in. Option number 2, and you might actually find this easier, is go back up here. Let's find out how many we're actually going to sell. Let's find, because I'm curious. I want to know how many customers I lost, right? So let's plug that 10 in here. Let's find out the number sold. If I plug the 10 in here, let's see, that's 500 minus 200. That's 300. So I'm only going to sell 300 this time, okay? And so now let's think about it this way. If I come back down here, it's saying, hey, I sold 300. And I sold them at $30 a piece. Well, if I want to figure out how much money I made, I take the number sold times the price. 300 times 30 gives me $9,000. Okay? Now, that still doesn't quite answer the question, so I've got a lot of good information here. I should increase the price 10 times, so I should sell them for $30. If I sell them for $30, I'm going to get an income of $9,000. But the question didn't say what's the income for this year. It says how much more will you make this year? So I have to go back up here, right there. This guy. Last year it was 5,000. Let me write it down here. This year it's 9,000. So that's an increase. So how much more am I going to make? I'm going to make $4,000 more. And really, what did I have to do in order to make that extra money? I had to do about 5-10 minutes worth of calculations, okay? This is why people do things like market research, okay? Market research is what would determine how many customers I'm going to lose as I increase the price more and more, okay? And companies do this all the time where they look at, and granted, theirs are much more complicated in this because there's lots of different factors. This is a very simplistic example. But they look at, hey, as we change this price, as we increase this, how is that going to affect our customer base? How is that going to affect the number we sell? And it all comes down to the bottom line. How much money are we going to make? Okay. So again, as you set these things up, that's the trickiest part. Okay. We really have to explore the situation. We have to come up with the separate values. And notice each of these, I came up with a value for length and width. I came up with a value for the number sold and the price, but it always involved two small expressions that I multiplied to get a quadratic. And then after we have that quadratic, we need to interpret what it's asking us to find. Is it asking us to find the x-intercepts? Is it asking us to find the vertex? And if so, which piece of the vertex, okay? So we have to do that little bit of interpretation and then continue to use those values to answer the questions, okay?